before it became the arid giant we know today as the Sahara Desert. This region had a completely different reality. About 10,000 years ago, during a period known as the Holocene, the Sahara was a land of lush savannas, rich in vegetation, and sustained by generous rainfall. The landscape was dotted with large lakes, which provided vital habitats for various species of animals and plants, and were central to the human communities that thrived there. During the so-called African humid period, also known as the African maximum, the Sahara displayed a landscape surprisingly different from what we see today. In this era, which lasted several millennia, the climate conditions were much more favorable, with frequent and intense rains regularly bathing the region. This abundance of water transformed the usual arid desert into a vibrant and rich savanna. With fertile land and lakes filled with water, a diverse ecosystem emerged, populated by large herbivores roaming the plains, closely followed by predators in search of prey. This era of abundance led to an explosion of life, with flora and fauna flourishing in an environment that seems inhospitable to us today. But what turned this fertile and populated land into a lifeless desert? The desertification of the Sahara has captured the attention of scientists for decades, given its significant impact on biodiversity, ecosystems, and human communities. One aspect studied by archaeologist David Wright is how human activity, specifically excessive grazing, may have contributed to this phenomenon. He suggests that such activity increased the region's albedo, a measure of how effectively a surface reflects sunlight back into space. A higher albedo can reduce the amount of solar energy absorbed by the Earth's surface, contributing to soil cooling and moisture reduction, accelerating the desertification process. On the other hand, Jessica Tierney, a geologist and associate professor of geosciences, points to natural factors as the main drivers of the changes in the Sahara. She highlights changes in the Earth's orbit and vegetation feedbacks as essential components in this process. Orbital changes, such as precession, alter the amount of solar radiation received in different parts of the planet in cycles of about 21,000 years, which can cause significant climate variations, like wetter periods that favor vegetation proliferation. Paul Valdez, professor of physical geography, along with Edward Armstrong and other colleagues, used climate models to analyze these humid periods in North Africa. They confirmed that orbital precession cyclically influences the region's vegetation, which in turn has profound implications for the dispersion of species, including humans. These humid periods are crucial because they allow the expansion of habitats and consequently the movement of human and animal groups that depend on these ecosystems for survival. Sumant Nigam, an atmospheric and oceanic scientist, and his team at the University of Maryland, after analyzing precipitation data, concluded that the Sahara has expanded by approximately 10% since 1920. They observed that this expansion can be attributed to both human-induced climate changes, such as increased greenhouse gases, and natural climate cycles. This interaction between anthropogenic and natural factors suggests a complex feedback mechanism that continues to shape the desert's boundaries and characteristics. Beneath the scorching sands of the Sahara Desert lie secrets buried for millions of years, revealing a history very different from the arid landscape we know today. This desert, the largest in the world, was once a flourishing ecosystem, full of rivers and lakes, supporting a diversity of life that challenges the imagination. Among the most fascinating finds are the fossils of Spinosaurus, the largest land carnivore ever discovered. With its distinctive dorsal sail, this dinosaur is believed to have had semi-aquatic habits, an unusual adaptation that set it apart from other large predators of the Mesozoic era. The discovery of such creatures in the Sahara not only challenges our understanding of ancient ecosystems, but also illustrates a dramatic transformation from lush aquatic habitats to desert expanses. In addition to dinosaurs, the Sahara was also home to a rich diversity of prehistoric mammals, as evidenced by fossils of elephants, giraffes, and hippos. These large mammals roamed the savannas that once covered the region, feeding on the abundant vegetation that characterized this ancient ecosystem. Interestingly, remains of a giant feline, the Barbarophalis, have also been found. This predator, with its impressive fangs, is a reminder that the Sahara was once home to species unparalleled in modern times. These findings highlight a story of adaptation and change, where large mammals thrived and adapted until climatic and geological conditions began to change drastically. The Sahara's historical wealth extends beyond paleontology, marked by substantial evidence of ancient human occupation, such as stone tools and rock art. These artifacts, some dating back thousands of years, are testimonies to the communities that once thrived in this green oasis. The rock art, depicting wildlife and daily activities of ancient Saharan civilizations, offers a window into understanding how humans interacted with their environment before it transformed into today's inhospitable landscape. This contrast between the green past and the arid present is a poignant reminder of the radical environmental transformations that can occur on Earth. More intriguing discoveries include fossilized human and animal footprints, which are true records frozen in time, showing the direct interaction between the ancient inhabitants of the Sahara and the animals they shared their world with. These footprints, found in various locations across the desert, are not just biological traces, but also emotional narratives, capturing fleeting moments where humans and animals crossed paths. These evidences dramatically contribute to our understanding of ecological adaptations and interactions in prehistoric environments, and are key to unraveling the complex patterns of human migration and occupation in the region. Wadi al-Hitan, or the Valley of the Whales, is a fascinating region located in Egypt's western desert, specifically within the protected area of Wadi el-Rayyan, Fayum province. This site is world-renowned for its spectacular whale fossils, particularly the extinct species Basilosaurus. During the Eocene period, which dates back about 40 to 37 million years, this region was submerged, part of the extensive and shallow Tethys Sea. Understanding this ancient marine environment is crucial, as it provides context on how and why these fossils were deposited there. The Tethys Sea was a thriving habitat for a variety of marine life, including large marine mammals like the whales we now find fossilized. The exceptional quality of the fossils found at Wadi al-Hitan is due to the unique preservation conditions that prevailed at that time. After the death of these marine giants, their bodies sank to the seabed, where they were quickly covered by sediments. This rapid burial is vital for fossilization, as it isolates the biological material from oxygen and decomposing organisms, preserving not only the bone structure, but also more detailed evidence, such as skin marks, stomach contents, and even the final position of the bones. Such a level of preservation offers an unparalleled window into the past, allowing scientists to reconstruct with high fidelity the anatomy and lifestyle of these ancient marine mammals. A curious fact. An intriguing curiosity about the Sahara Desert is the presence of underground freshwater lakes, known as aquifers. In contrast to the arid and relentless landscape that characterizes the surface of the desert, extensive reservoirs of freshwater lie hidden beneath the sands, forming true underground oases. These aquifers are remnants of past eras when the Sahara's climate was much wetter. Over thousands of years, during periods of higher precipitation, rainwater infiltrated the soil, accumulating in layers of porous rock beneath the surface. This process formed large reservoirs, which are now vital sources of water for many Saharan communities. The most notable of these aquatic systems is the Nubian Sandstone Aquifer System, one of the largest underground freshwater reservoirs in the world, spanning 4 countries: Egypt, Libya, Chad, and Sudan. This aquifer is so vast that it contains enough water to fill the Black Sea. In our journey today through the Sahara Desert, we've discovered that beneath its vast and relentless sands lie surprising secrets and relics of times past. From fossils that tell stories of ancient marine life to enormous freshwater reservoirs that defy the dryness of the surface, the Sahara reveals that even the most arid environments on our planet are full of mysteries waiting to be explored. If you enjoyed uncovering with us what lies beneath the sands of the Sahara and want to continue this adventure into more mysteries and wonders of our world, don't forget to subscribe to the channel and activate the notification bell. That way, you won't miss any of our explorations and will always stay updated on the latest discoveries. Watch the video where we talk about Titan, Saturn's moon that might harbor life. Join us on this ongoing discovery of the most fascinating secrets of Earth and beyond.